At the TX valve, the amount of liquid refrigerant flow is determined by the action of a spring-loaded valve, which is controlled by different pressures on each side of a connecting diaphragm. The pressure in chamber A is determined by a temperature sensing bulb, which is taped to the evaporator outlet and insulated from air temperatures. The sensing bulb is filled with refrigerant and is connected to chamber A by a capillary tube. The temperature at the evaporator outlet determines the pressure in the bulb. Higher temperatures will give higher pressures, and this will tend to open the valve wider and allow more refrigerant to flow through. Lower temperatures will give lower pressures. This will tend to close the valve and reduce the flow of refrigerant. The pressure in chamber B is determined by the refrigerant pressure in the evaporator and by the force supplied from the valve spring, often called a superheat spring. The spring is designed to ensure that the temperature of the refrigerant leaving the evaporator is between 2 degrees Celsius to 9 degrees Celsius higher than the boiling point of the refrigerant at the current operating pressure. This difference in temperature is called superheat, and it ensures that all liquid refrigerant which enters the evaporator is vaporized before it leaves. When the compressor switches on, the suction from the compressor removes refrigerant vapor from the evaporator and lowers its pressure. This reduces the pressure in chamber B and allows the pressure in chamber A to move the valve away from its seat by the action of the diaphragm. High-pressure liquid flows through the orifice and enters the evaporator as a low-pressure liquid. The liquid expands into the larger volume of the evaporator, causing a reduction in its pressure, and this, together with heat from the air passing over the evaporator fins, causes it to vaporize. The temperature of the refrigerant leaving the evaporator is interpreted by the sensing bulb attached to the outlet. If the temperature is low, the refrigerant in the sensing bulb will contract, and pressure in chamber A of the TX valve will reduce. The diaphragm moves, and the valve moves towards the valve seat to reduce the quantity of refrigerant entering the evaporator. If the temperature is high, the refrigerant in the sensing bulb expands and exerts more pressure in chamber A, causing the valve to move away from its seat and allowing more refrigerant to enter the evaporator. The amount of refrigerant flowing depends on the quantity of heat to be removed from the air passing over the evaporator fins. More heat means that more refrigerant is required to remove it. Less heat means that less refrigerant is required. A number of control devices are fitted into the system to ensure maximum efficiency, and these operate as described in the section on the fixed orifice system.